Unlike the majority of the presenters from ChemAxon in the last, bit more than one day, I will not be talking about a readily available product from our portfolio. I will be talking about something that we have just started, a new product development, and I would like to hear your opinion about it. So please, let's discuss this after the presentation, maybe in the coffee break. As a start, I would like to refer back to Ákos's presentation from yesterday, where he has pointed out the importance of information gathering at certain points of the design and discovery project. And I think he has shown a really elegant example of a pre-processed data set and applying MMP analysis on that data. But that's, of course, not the only kind of data source that you will need to use in these projects. One other example could be a set of supplier databases. So typically you might or you will want to search for analogs or the actual members of the series that you are looking at in supplier catalogs to overcome the very typical availability bias. Or something very similar applies when you are planning a synthesis and you are trying to find the best availability of building blocks for your synthesis path. And that does not only apply for vendor catalogs, but also for your internal compound collection as well. Another example is when you are looking at available experimental data, which can be binding results, toxicity results, and so on. Whatever is available for the compounds that you are looking at, or for analogs of your compounds. That can be also crucial in certain points of the design process. And of course, the intellectual property information. In a certain stage, you will really want to make sure that you are not violating any patents. That can be a go, no-go decision influencer for your project. So if you look at this picture, I'm sure that many of you already have some favorite data sources for these problems, and you don't have to look at all this mess. But still, you have the feeling that you might want to tidy this up a little bit. So tidying this up is in order. I'm not sure how many of you know Ursus Wehrli. He's a really brilliant artist from Switzerland, and he has many publications that go under the title Kunst aufräumen, which means something like tidying up art. So he disassembles famous artworks and puts together the pieces again, creating a completely new meaning by that. And he also does that with objects. So I think this is a good analogy to what we are trying to achieve with database. We want to tidy up chemistry content. But if you want to do that, you will face a number of challenges. And here's one example. You have heard Andrei's presentation from yesterday. I think his first presentation was given 2 years ago at this UGM, where he was only talking about 171 million compounds in their virtual database. And we were very happy that our MATFAST similarity searching was handling this without any problems. We are still handling their database without any problems. But only 1 year later, he was already talking about almost double the size. And at the end of the same year, 2018, it was already 420 million. Earlier this year, they have released the 720 million compound dataset, which he was talking about yesterday. And only he can tell what will be the next number, or maybe even he cannot tell that. So we don't know, but it's definitely increasing, yet it will not decrease again. Another challenge can be understood from the molecules example, where they are releasing their data sets monthly, I believe. This is just the tendency from 2016. You see the growth from 7 million to 22 million today. What makes it interesting is the number of changes that you have to apply if you want to incrementally implement these new data sets. In some cases, the sum of rows that need to be added or deleted are in the millions range. So that's also tricky. Potentially, these challenges are the reason why chemists still have to go to each of these databases one by one when they want to find the relevant information that they are looking for. And that's a problem. So our vision is to tidy this up and provide chemists with a service that contains all the relevant, the necessary chemistry information that is sufficient to serve their discovery purposes through a single service, single interface. The interface could be a design application, for instance, Marvin Life, but could be other as well. But of course, there must be some way to access this with third-party applications, so it should be integratable. So what we did was we built a prototype, which consists of these 7 databases containing roughly 140 million compounds in total. We deduplicated this set and created a master compound collection with roughly 130 million unique structures. We also did some standardization, but we were not very strict, so it still contains probably some nonsense. And we had put the whole thing into PostgreSQL and indexed the master table with the new PostgreSQL cartridge. Now, that allows you to do substructure and exact structure searches, also to some extent similarity searches, but if you want to do more sophisticated similarity-based searching, then you will need the MathFast Similarity search engine as well. So we have also included that and applied that on the same data set. Now, what is obviously missing from here is the enum real that I've been talking about so much so far. We have also added that one, but separately, and we have indexed that with the new JChem microservices. This had some technical reasons. For now, I hope that this is sufficient. We have consolidated this backend and had put the Marvin Live frontend on top of it with a very simplistic user interface, so that this huge amount of data, in total, this is almost 900 million compounds, 900 million meaningful compounds, can be actually accessed by chemists. Okay, so what we have now is something more than a prototype. Actually, we are getting quite close to the vision that we have set for ourselves, and we have a relatively easy way to access this data, a simplistic, maybe primitive, but a good way to access this data. So what comes next? Well, now comes the fun part, of course. We are validating the concept, we are validating the use cases, and we are working out the requirements, and we are starting the development as well. And we hope that from the sketches that we have drawn on paper just a few months ago, we will get something that will be pleasing to the eye, pleasing to the chemist, and pleasing to the design process itself. Now, you feel that we are still in a relatively early phase of this development. And yeah, I feel like these ancestors of ours in this drawing of Gary Larson, another favorite of mine, we see the obvious. Maybe not even all the obvious, but we see a few things. But I would really like to involve you in the discussion and help us understand what we are missing beyond the obvious and how we can proceed best. So please find me in the break if you have time and if you're interested, and thank you very much for your attention.